Okay, this is the first example for the chapter truss, and we use the joint method. Okay, the first thing you need to do for truss first is check for zero force member. Okay, and when I ask you the question on the online quiz, it could be the answer could be there is no zero force member, there is one, there is two, there is three. Okay, anything is possible. So if we look at this one, is there any zero force member? Look at this joint B. At the joint B, what do we have? We have two collinear member and a third one that is not collinear to those two, and we have no load that's applied. So if we do the sum of the forces on Y at the point B, okay, it's equal to 0, we necessarily have this one is equal to 0. So dB, it's a zero force member. So dB is a zero force member. Okay, two, there's different option. I will say, can you solve two unknown at the joint, and it could be joints at the joint where you have external load. I will explain that external load. Okay, so let's look at the point where we have external load is at the point D. So at the point D, are we able to solve for two unknown? So if we have one unknown in AD and one unknown in DC. Okay, because this one is zero force members, we just have two unknowns. So yes, we are able to solve for AD and DC using the joint D. Okay, so there's two options. Options A, yes, we can. So let's go. Okay, and there's an option, no, we can't. Okay, so if we can't solve at the joint where we have an external load, and maybe we just have this joint with an external load, what can we do? We can find the reaction at A or A and C. Okay, so let me do that. So what do I mean? I mean that we can consider the truss, everything together, without looking at how it's made inside. Okay, this is now a rigid body. This is a rigid body, and we will solve for NA, CY, and CX using the force that we know for 90 pounds. And we can, because in this case it's a rigid body, and with the rigid body equation of equilibrium, we have three equations: force on X, force on Y, and a moment. So we will use the moment about C to find NA. After that, maybe the force on X to find CX and the force on Y to find CY. Okay, but it's only if you cannot begin to solve with your joint D. That is not our case. Okay, so let's remove that. And let's not do that. Let's make it easiest way. So don't forget that this one is 0, so we don't consider it. Okay, so can we solve for two unknown at the joint where we have external load? So yes, we can. So let's solve for D. So first, 3W diagram. Let's see. I will have a lot of things to write. Okay, so I will do it there. Okay, I will write my steps on the left and do it there. So I do my free body diagram at D. Okay, free body diagram at D. First steps. That's kind of my second steps because the first steps was just to check the zero force member. Okay, so we have the point D. We have one force that we know. That is the 450 pounds. And we have forces from AD and DC. Can we guess the direction? We know that they are in opposite directions, but we don't know if it's plus or minus. Let's put both in tension. So that's my force FAD, and that's my force FDC. Two unknowns only. Nothing in BD because it's a zero force member. Okay, we need some angle there, and you see it's 4 feet, so it's 45. So we have 45 degrees and 45 degrees, and we need some axes. So let's use X. Oops, X and Y. So now we can solve. So let's solve for using this 4-bit diagram. Okay. I try to be organized. So sum of the forces on X is equal to 0. We have a trouble there because there's 2 unknown on X and 2 unknown on Y. But no worries, we will be able to solve that. So force on X, we have minus FAD sine 45 plus FDC cosine 45 minus 450 is equal to 0. We cannot do anything with that. Okay, so let's leave it this way. Now the sum of the forces on Y it's equal to 0. So this one say that minus FAD cosine 45 and minus FDC cosine 45 it's equal to 0. Okay, so we can divide by cosine 45 on both sides. So it means that FAD is equal to minus FDC. So they have the same magnitude, but they will be in opposite direction. One is going down and one is going up. Let's replace FAD by minus FDC in this one. Oops, substitution. So we have FDC. So FAD, let me check. Yes, minus plus. So FDC sine 45 plus FDC sine 45 it's equal to 450. Okay, so FDC it's equal to 450 divided by 2 sine 45 degrees. Oops, and it's 450 divided by 2 sine 45, don't forget your parentheses, 318 pounds. So for FDC, we guess the right sense, the right direction. So it's the right directions. So it means that it's in tension because the member is pulling on the particle, so the particle is pulling on the member. Now FAD is equal to minus FDC, so FAD is equal to minus FDC, so it's equal to minus 318. So it means that it's equal to 318 in compression because we didn't guess the right direction. So it's 318 in compression, this one. So instead of being in this direction, and I will use a green, okay, it's mean that FAD is in this direction. Okay, so we solve our two first members. So we find 318 compression and 318 tension. Okay. Okay, now, okay, so we solve. Okay, now go to the next joint. Okay, so there's two next joints. So we did D. So now we can use A or C. Which one? We need only two unknown, no more. If we look at the joint A, what, okay, let's write in blue what we know. Now we know that 318, and this one is going up, so this one is going down. And this one is going down, FDC, so it's going up there. Okay. That's the forces that we know in blue. The forces that we don't know, there's a force there that we don't know on both sides. At A, it's a roller connection, so there's a force from A that we don't know, and A. And at C, there's two forces that we don't know, CY and CX. So at C, we have three unknown. We can't solve at C. At A, we have two unknown, so we can solve at A. Okay, go to the next joint and pick a joint with one or two unknown. No more. Okay, otherwise we cannot solve. Okay, so now we will do the joint at A. Okay, let's do it there. So 3, I will make it there. 3 free body diagram at A. So just go there so you can see the graph, and we can see also the free body diagram at D. So free body diagram at A. All right, so big. 3 free body diagram at A. Okay, so we have the point A. That's my point A. We have the red unknown force NA, that is vertical. We have the force going down of 318. Compression, so compression, the member push on the particle and the particle push on the member. So remember that our um, our body, our particle is the pin right now, and we have a force AB there. And can we guess if it's going right or left? Because of this one is going left, it has to go to the right. So FAB is going to the right. So it means that the member is pulling. So it means that it will be tension. Okay, so let's solve for FAB, and we need two axes, X and Y, and we also know that this angle is 45. So what do we use to solve for FAB? We use the force on X. So sum of the forces on X is equal to 0. Okay, so it means that minus 318 cosine 45 degrees plus FAB is equal to 0. So we find FAB, that's equal to 318 cosine 45. So 318 cosine 45, and it's 225 pounds. And we're good because the question was just, oh no, we're not good. Tension, because it's plus, so it's in the direction that we guess. So we guess that it was going to the right, so it's going to the right, and going to the right means tension because it's pulling together. So now we can write on our diagram that this one is 225 pounds. Oh, and we found this one. Okay, we found this one. What about this one to the right at B? So at B, if we do the diagram at B, slowly, fast, because I know that my problem are so long. So we have this force going to the right, so force going to the left, that was a 225. This one is a zero force member, so we have a force to the right. So necessarily it's also 225 member. And because it's pulling 2, it's also tension. Okay, so if you have member like this member and this member will have the same magnitude and same direction, tension or compression. Okay, and you can write it right away. So 225 is everywhere there. Everywhere. 225, 318 in compression and 318 in tension. Okay, the question didn't ask for the reaction at A and C, so don't solve for the reaction. except if you need it to solve it. Okay, so I will say this is kind of all our steps. I know I did them in different time, but if you follow step by step in the video, you will get it. Okay, so that's it for the first example. See you in the next video.